Alright, so I just wanted to share the results of my attempt at the programming project number 3 using the standard Zeus board and the breadboarded circuit connected to it, running through a null modem cable. That cable is going through a USB to serial adapter and then into my laptop. This is the actual main loop of the code. It's very short. This is where you spend all your time. You're just sort of sitting in a loop, waiting for the timer to expire. Every time the timer expires, this is the 1 Hertz real-time clock. It sets a variable, and in this loop I just wait until that variable's set. That tells me a second has passed. I count off a number of seconds, and then I exit this delay loop. The main program itself calls a delay loop and then toggles the LED and just keeps doing that forever, and the amount of delay it executes is read from memory, and that memory value gets changed when the interrupt-driven switch is toggled. So I can come over here, I can do my usual Go script to assemble and link and create an ELF file, and then I can run insight. And insight is the usual drill. Go ahead and connect to the target. That works fine. Go ahead and download. Get your download script. That all worked fine. Hit the runner icon to start. Answer yes to the question it always asks. And then just hit the continue button. And now your code is flying. And sure enough, our LED is blinking, and it's going on for a second and off for a second at this nice steady pace. And if I hit the switch, it will change to staying on for 2 seconds and then off for 2 seconds. And if I hit it again, it will go to being off for 3 and then on for 3. And then if I hit it again, it goes back to a 1 second period on and 1 second off. And when you're testing your circuit, if you're using well, even if you're not using the real-time clock, if you're testing your circuit, this switch is interrupt-driven, so even though you're in the middle of a timing loop and you're doing something, anytime you hit this switch, the interrupt code should be called and it should adjust the timing parameter accordingly. So right now the timing parameter is set to 1. I can start pounding on the switch. I can set it to 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, and it should have no problem keeping up with that, and now my timing parameter is in fact 3. And you can confirm that by hitting it once more and seeing that it goes back to 1 second. So that's the basic code. There's some details that I had to figure out, and I will share those with class tonight. And hopefully people are on their way to making this program work, taking it apart and working on small steps and putting those steps together and building it up in a methodical way. So have fun.